Students, again I am making this video for English medium students, so welcome in my channel. Due to high demand of some students, I am making again this video. So look at this Coulombs law. Today we are going to discuss about Coulombs law and principle of superposition. So Coulombs law is what? There are two charges. Look at here, there is Q1 and Q2. Two charges are there and distance between these charges are small r. It is small r. So force between these two charges is directly proportional to Q1 Q2. According to Coulomb, the force between two charges is directly proportional to the magnitude of these two charges. Q1 is magnitude of first charge and Q2 is magnitude of second charge. It means multiple of magnitude of these two charges. So this is equation number 1. Similarly, this force, you can say electric force. Electric force is inversely proportional to r square. It's inversely proportional to the square of the distance between these two charges. So it is F proportional to 1 upon r square. If we combine these two equations from equation 1 and 2, it can be written as F is proportional to Q1 Q2 upon r square. This is proportional sign, so if we remove it, then F equal to K Q1 Q2 upon r square, where K is known as proportional constant. It is a proportionality of constant of proportionality, you can say, and its value is 9 into 10 raised to 9. 9 into 10 raised to 9, and its unit from this equation 3 we can find the dimension or unit of K, and we can also find dimension. So K is equal to F into r square upon Q1 Q2. From this one, look at here, if we cross multiply, K equal to F into r square upon Q1 Q2. Okay, so unit of F is Newton, unit of r square is what? It is meter square upon Q1 into Q2. It means Coulomb into Coulomb square. So K is what? 9 into 10 raised to 9 Newton meter square per Coulomb square. It is a value of K which is proportional constant. In other words, K can be written as 1 upon 4 pi epsilon naught, where epsilon naught is a constant. It is called permittivity of vacuum. Permittivity of vacuum or air. Clear? Epsilon naught, permittivity of vacuum, and its value is 8.85 into 10 raised to minus 12, and its unit, look at here, 4 pi is a constant, epsilon naught is also constant, but it has some unit. Epsilon naught, unit of epsilon naught is just reverse or inverse of K. Okay, so unit of K, so if we invert it, then it become Coulomb square upon Newton meter square. Coulomb square upon Newton meter square. So this is unit of epsilon naught, which is known as permittivity of vacuum or air. So F can be written as F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon r square. Q1 Q2 upon r square. Okay, so this force is acting between two charges when there is no medium. No medium means vacuum, you can say. It is vacuum or air. Clear? F naught, I am denoting here F naught. So F naught is what? In case of force acting between these two charges when there is no medium, so F naught is 1 upon 4 pi epsilon naught Q1 Q2 upon r square. Clear? Number again 4. So force acting between these two charges in vacuum, when the system is in place vacuum, so F naught is this one, 1 upon 4 pi epsilon naught Q1 Q2 upon r square. Suppose there is some medium, there is no vacuum, there is no air. Suppose there is a medium, then force between these two charges is what? So epsilon naught is permittivity of vacuum. If we put some medium between these two charges, then force acting between these two charges is, say, Fm. Fm means in medium, or you can say 1 upon 4 pi epsilon. In place of epsilon naught, this naught is denoting there is no medium, it is epsilon. Epsilon means it's a permittivity of medium. Q1 Q2 upon r square. Distance is same, charge is same, but medium is there, epsilon. So epsilon is what? It is a permittivity of medium. So Fm is this. Now look at here, epsilon equal to epsilon 0 epsilon r, epsilon upon epsilon 0. There is a relation. Epsilon is permittivity of medium, epsilon naught, it is a permittivity of vacuum, epsilon r, it is relative permittivity. It means ratio of these two. Okay, permittivity of medium with ratio permittivity of vacuum. This is called epsilon r or relative permittivity, and it is unitless. If it is unitless, then it's also dimensionless. Okay, so epsilon r equal to epsilon upon epsilon naught. So look at here, epsilon can be written as epsilon naught epsilon r. From this equation, epsilon r epsilon naught, this one. So if you put value of epsilon here, epsilon naught epsilon r, then we find Fm equal to 1 upon 4 pi epsilon naught is epsilon naught, epsilon is epsilon naught epsilon r q1 q2 upon r square. Clear? So this is equation number 5. This is force between two charges when there is no medium. This is force between two charges where there is some medium. So this is F1. Now look at this one and this one. 1 upon 4 pi epsilon naught q1 q2 upon r square. 1 upon 4 pi epsilon naught, if we 4 pi epsilon naught q1 q2 upon r square. So this can be written as this one, f naught. So Fm is what? It is f naught upon epsilon r. So this can be written as epsilon r is equal to f naught upon Fm, or another definition you can say it is epsilon upon epsilon naught. So this is a second definition you can say of relative permittivity, f naught upon f. F naught means the charge, the force between two charges when there is no medium or vacuum. Fm is the force between two charges when there is some medium. So F naught upon Fm is known as epsilon r. It is also known as dielectric constant. So value epsilon r. So value of epsilon r is between 1 and infinite. Value of between its minimum value is 1 and maximum value is infinite. So look at here, epsilon r is almost equal to 1 for vacuum or air, or vacuum. Epsilon r is infinite for you can say conductor or metal. For conductor its value is infinite, and for vacuum or air it is value of 1. So if you put value of 1 here, if you look at here vacuum, then value of epsilon r is 1. So put here 1. Then this equation and this one is same. Clear? If there is no medium, epsilon r equal to 1. So force is maximum. Second thing, if we put epsilon r equal to infinite for metal, for conductor, then if you put here infinite, then something upon infinite is equal to 0. So again we can write this one. If epsilon r equal to 1, then look at here, force equal to k q1 q2 upon r square. K is, from this equation, k is 1 upon 4 pi epsilon naught. If you put epsilon r equal to 1, then force is maximum. Second thing, if we put epsilon r equal to infinite for metal or conductor, then put here infinite. In place of epsilon r we put infinite, then something upon infinite is equal to 0. Very important point. If medium is conductor or metal, in other words you can say metal, then force between these two charges is always equal to 0. So it is also, we can say, minimum. Clear? So force between the two charges, these two charges, is maximum when there is no medium or air, and the force is minimum or 0 between these two charges when the medium is what? Conductor or metal. So this is very important point, and this is all about Coulombs law. Coulombs law in electrostatics. So in general we can say Coulombs law tells us about the force between two charges. Clear? So this is all about, as I told you, Coulombs law. Now look at, generally this question comes in exam, asked in exam, that there is two charges. If we connect these two charges by a metallic wire, question is what? There is two charges. If we connect these two charges by a metallic wire, then what is force, net force on these charges? So net force is 0. One thing more, if there is two charges, suppose q1 and q2, what is the direction of force? Direction of force is always along this line. Keep in mind, always direction of force is along this line joining to these two point charges. Coulombs law is always valid for point charges. Keep in mind. So this force this charge force acting force on this charge, and same as q2 is applying force this q1. So you can say this one. Clear? Now next point is superposition, principle of superposition. I hope you are getting. So principle of superposition is principle of superposition. Principle of superposition is what? Suppose there is one charge, look at here, this is charge q0, okay, and around this charge there are many charges. Suppose this one is q1, this one is q2, and this one is q3. I am taking these three charges around this charge. q0 is in center, and q1, q2, suppose this one r1, r2, and r3. Distance between these two charges. So net force on this charge is what? Suppose first charge applying force on this charge is F1. First charge applying force on this charge is F1. Second charge applying force, this one is F2, and third one is F3. So this is total force on this charge Q0. Okay, so in simple word, this is principle of superposition. So in definition, in other word, we can say total force on a particular charge is vector sum of force acting on this charge due to different charges. It means F on this charge is equal to F1, F2, F3. It is vector sum, vector addition, you can say vector sum or vector addition due to vector addition of this force is equal to total force on this charge. So this is known as principle of superposition. This principle generally we used when total or resultant, when we are going to find net force. When we need to find net force on a particular charge, then we use this principle of superposition. Clear? In interference it is also used principle of superposition. So in general I can say total force, whenever we going to find total force on a particular charge is what it is, vector addition of different vector addition of force due to different charge q1, q2, q3, maybe q4, q up to qn. So this is principle of superposition. So students, you I hope you understand all these things. So like, share and subscribe this channel. One thing more.